Yo, what's up, guys? Welcome back. Um, Still a little bit sick, low key. But yeah, we're gonna record a video today. Um, Maybe you can tell a little bit of my voice that I'm a little sick. I don't know, but anyway, let's jump onto Leetcode. Oh, actually, we forgot our Pokemon sound of the day, episode 68. We got a Machamp. Let's take a look at the sound.
So you think you know Wix, do you really? First up, we've got Shake video masks.
Oh my gosh, dude. Whoa. Okay, there's the first one. That's the first one. Sorry, that was like the weirdest sound I've ever made. Alright, we'll listen one more time and then we're gonna get into it. Alright, it's nice. What a video. What a video. Jeez, man. Okay. Okay. Sorry, I just had to check my email real quick. Yeah, no, I think we're good. Okay. Yeah, let's jump into a problem here. Let's check out what our problem of the day is. House robber 4. Is there a house robber 1? Maybe we should start from house robber 1. So, some money inside. There is also a robber who wants to steal money from the homes, but refuses to steal from adjacent homes. Given an integer in nums representing how much money is stashed in each house. Okay. No form of the ith house from the left has nums I dollars. You're also given integer k representing the minimum number of houses the robber will steal from. It is always possible to steal at least k houses. Return the minimum capability of the robber out of all the possible ways to steal at least k houses. As in it's 1 and 3 capabilities numbers 1, 3. Return 5995. There are always 7 ways to rob the houses, the way which... Interesting problem. I'm thinking here we could do a double for loop, but is that gonna... Binary search, dude. Oh my gosh, bro. I just don't think I'm good enough with binary search yet, bro. There's a 100% chance it's binary search. Okay. I understand that it's binary search, but I just don't. I don't really know how to implement it, to be completely honest. It's really hard for me to think about the low and the high here and how we can use that in order to solve this problem. I don't know. I don't think this is a very simple problem, to be honest. House robber, IP, Leetcode.
Think your taxes are simple? You could file for free with H&R Block. More people qualify for H&R Block free online than TurboTax.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem, House Robber 4. If you haven't solved the first 3 House Robber problems, I would definitely recommend at least solving the first one. I think we've solved 1, 2, and 3 on this.
Okay. I'm going to solve the first problem. Only because... let's go to House Robber 1. You're a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that the adjacent house have security systems connected and will automatically contact the police if 2 adjacent houses are broken into at the same night. Given an issue of rain numbers representing the number of houses, you should return the maximum amount of money you can rob tonight without alerting the police. Is it not a... Okay. I just... I know we can use an O of n squared approach and do this. But will it accept an O of n squared approach? Maybe it would. I don't know. Let's see. I don't know. J in range length nums. I think we want to start from. Oh well, I guess we can kind of start from the same. First, we need to check. Well, if I is if j minus I is greater than or equal to 1, then we have a valid. So then we can, the max create a max res here. Inside this if statement, we can check, well, if we can do and is equal to nums I plus nums j, and then we can max res is equal to and max res and we could just return max res. I think this solution should pass. Nope. Oh, output. Jeez, man. What the hell is going on here? And output 5. Output 16. I don't know, maybe putting parentheses around this. Would this pass? Well, honestly, if j minus I is greater than or equal to 1, I feel like that shows the distance is at least 1. Because if it's 0, right? We're here. Oh no, okay. 2 minus 0 is 2, so that works. 0 minus 3 minus 0 is 3, so that works. 1, 3. Maybe it's meant to be 2. Okay, why is this not passing now? How's the expected 12 here? So 9, 11, 12. Okay. So we're only adding 2 values. Okay, that's our issue. How can we make this 3 values potentially? Maybe O and squared solution wouldn't work. How can Oh wait, are we given a K or something? No. Okay, what are we doing here? This house must be robbed. Okay, we'll deal with that later. Okay, so I know what my issue is, but I think, oh man, house robber 4. Nico, house robber.
Okay, let's solve Leetcode
Python dynamic
198
programming.
house robber. In my opinion, this is such a good question to understand. Even though it's just an easy question, you can learn so much about dynamic
Is it an easy
programming
question?
from this problem.
Medium.
And you might already know, Google really loves asking dynamic programming problems, and if you want to get started on that, this is such a good question to understand. So we're basically given an array of integers, like many problems, And each integer represents a house, right? So this is a house, this is a house, this is a house. They're all houses and they're adjacent to each other. So it's basically a neighborhood. We want to rob houses to maximize the amount of money we can rob. So why not just rob all of them, right? Nope, there's a restriction. We can't rob two houses that are adjacent to each other. So we can rob this house, but then we can't rob this house, right? So we have to rob this one next, maybe, right? On the other hand, if we rob this one, we can't rob this one and we can't rob this one. It has two neighbors. This might sound really difficult, right? So let's just start out with the brute force approach. Let's imagine if we were trying to get every single combination. Okay, so the first combination is where we pick the first house, right? So let's draw out what the decision tree of that would look like. Okay, so our first decision was to rob the house with value 1. Okay, so next we want to rob more houses, right? But we can't rob this one. So we have to basically get the max we can rob from these two. So does that sound kind of like a sub problem? Yeah, but we'll get there in a minute. So continuing on with just the brute force, right? Okay, so now we want to rob these two houses, right?
I was looking at my phone. I gotta go
So
back.
the first combination is where we pick the first house, right? So let's draw out what the decision tree of that would look like. Okay, so our first decision was to rob the house with value 1. Okay, so next we want to rob more houses, right? But we can't rob this one. So we have to basically get the max we can rob from these two. So does that sound kind of like a sub problem? Yeah, but we'll get there in a minute. So continuing on with just the brute force, right? Okay, so now we want to rob these two houses, right? Well, we can't rob both of them because they're right next to each other. So we can either rob house 3 or we can rob house 1. So this is the decision tree, right? And so along this path, so if we were to rob house 1, right? Let's say we went along this path. Then we can either rob house 1 and 3, or we can rob house 1 and 1. Obviously, we're going to choose this one because that gives us the maximum, which is 4. Okay, but what if we didn't rob the first house? We decided to rob the second house. So that would be our other decision in our decision tree, right? Rob house 2. Okay, now we have not many choices, right? We can't rob house 3. So the only house left is house 1. So we rob that one as well. So if we went along this pathway in our decision tree, we would get these two houses robbed, and that's a total of 3. But we remember we found this, which was a total of 4, which is greater, of course, so that's going to be our result. Now, this is a very brute force approach. Imagine if we had more numbers here, right? Maybe a 3 and a 4, then we'd have to have like more paths in our decision tree. This could get very complex. So how can we improve it? Can we identify any sub-problem? And the answer to that is yes. Let's take a look at the sub-problem. So remember, we have two choices. We want to get the max that we can rob from this entire neighborhood. So the first choice is we rob from the first house and then find the maximum from the remaining houses, right? Imagine there's more houses here. There could be a 3, a 4, whatever, right? This is the sub-problem. We're finding the max of a sub-array of the entire array. The second choice we have is we skip this house, right? If we skip it, then basically we're saying, okay, find the maximum of the entire subarray, not including the first value. So let's actually write out the relationship if it doesn't make sense yet. So if we want to find the max we can rob from the entire array, we have two choices. Rob in this case indicates the max that we can rob from the entire array. So in our first decision,
Okay. I don't know, maybe if we're making another function to do this, but maybe can we do this in terms of slicing? I have no idea. Fine. I nums. We can do res is equal to. Let's just do cur is equal to. The max of nums I. Yeah. I don't know if this will work. This seems a little too max res. Max of max res. Okay. Turn max res. Mike is an empty sequence. Doesn't this slice into a new array, bro? Maybe we have to pass it in like that. I don't know. Max arg is. Why is this an empty sequence? Maybe this won't work. I don't know. What's the actual value of knobs on neck? Oh my gosh, dude. Am I that stupid? Like, for I length nums minus 1. Oh, wait. Yeah, we have to ensure the non-adjacent. That's only the number next to it. Bro, no way, bro. Like it's an empty sequence. Sequence. No, do we really need the length? No, we don't. Let's just make it the length of nums. Oh my gosh, yeah, nums I plus new array, the max of new array, if new array, else 0. Ooh. Okay. Am I missing something, bro? Okay.
decision, we decided that we were going to rob the first value. So array of index 0 plus rob the remainder of this blue portion of the array. So we're skipping index 1. We're going to rob the entire array from index 2 to the end. So I'll say n is the end in this case. So that's our first decision. If we decided to rob the first house, then we're going to break up the problem into a subproblem. Now we got to rob the remainder of that array, skipping one of the values. If we didn't rob the first house, then we simply only have the subproblem rob every house, skipping the first house. So we start at house 1, not house 0, and go until the end of the array. So this is the recurrence relationship. You might not know exactly what that means, but it's basically a way to break up dynamic programming problems. Notice the result of the entire problem depends on only these two. If we can compute these two, then we have our result. But notice each rob can be broken up into its own subproblem, just like we did over here. So let's actually solve the subproblems now before we solve the entire problem. Now I could do this in reverse order, right? I could say, let's find the max of this subarray, and so on, but it's a little more confusing to do that, so I'm actually going to do it in order. So let's start at the first house, like we've been doing. So if we rob this house, that's basically our base case, right? So we can decide to rob this house. In that case, up until this point, we could rob a total of 1. Okay, now we get to the second house. So what's the max we can rob up until this point? Well, we can decide to not rob this house and only rob this house if we wanted to. Or we can decide to not rob this house and only rob this house. 2 is obviously greater than 1, so I'm going to decide only to rob this house. Next we get to house 3. This is where it gets interesting. So what's the max amount we can rob up until this point? So we have 2 choices again. We can rob house 3 and we can rob house 1. Or we can just rob house 2. The max is obviously if we rob house 3 and 1, and in that case we'd get a total of 4. Now we get to the last value, 1. So we can decide to rob house 1, and if we did rob house 1, then we would want the max we could rob up until these 2 values, meaning we'd want 1 plus 2, because 2 tells us what's the max we can rob from these first 2 elements. We can't include this one because it's adjacent to 1. So one of our choices is 1 plus 2. That's choice 1. Or we can decide to not even rob house 1. We can just get the max of the entire first 3 elements, not including this one. In that case, we have what we would get from the first 3 elements right here. We already computed it. It's 4. So our choices are 1 plus 2 or 4. Obviously 4 is greater, so I'm going to choose 4. That means we put a 4 right here. And this last 4 means that for the entire array, the max value we could get is 4 if we wanted to rob houses. So we can put a 4 here. But notice how we don't even have to store this entire blue portion. For each value, like for this one, 4, to compute this, we only need to look at the previous 2 results that we computed. And the reason for that is because we could either decide to rob this one and rob the remainder portion of the array, not including 3, in which case we'd have the value computed right here. The other case is if we wanted the max we could rob from the entire array, we could decide to not even include this and just get the max from these 3. And in that case, the value would be stored here. So now let's look at the code. Since we only need to maintain the last 2 maxes that we could rob from, we'll only need 2 variables. So I'll just name them rob1, rob2. We'll initialize them as 0, because if we get an empty subarray, we want to return 0 anyway. So let's iterate through each of the houses we can rob. And now we want to compute the maximum that we can rob up until this value n. So I'm going to compute that in a temporary variable for now, and you'll probably see why. So the max we can rob up until now, in my case, I'm going to say rob1, or rob2 was the last house that we robbed. Rob1 was the one before that. So knowing that, the max we could get would be n plus rob1, meaning there's a gap between the current house and the previous house, or rob2, which includes the previous house. In case it's not clear, this is basically, let me just make a comment to show what I mean by rob1 and rob2. So rob1 is first, rob2 comes second, and then we get some more values, n plus 1, and so on. So if I want to rob n, then I have to rob 1 as well. I can't use rob 2. But if I want to do rob 2, I can include n because it's right next to it. So when we iterate to the next position, meaning we get here, we want to update rob 1 to now equal rob 2. So let's do that. And rob 2, in this case, wants to be updated to n. So rob 2 can now equal our temporary value that we just computed. At the end, we want to return rob 2 because by the time we get to the end, rob 2 will be equal to the last value, meaning that it will be the max we can rob from the entire neighborhood of houses. This is a problem you can learn so much from. Even though it's an easy problem, it might take you a while to digest exactly what's going on and to understand all the importance of this problem. So many dynamic programming problems are built upon this one. And let me know if you have any questions, because I feel like I might not have explained the recurrence relation.
Wow. Interesting problem. Let's take a look and try and understand what's exactly going on here. We can change ours to for I in for I. Wow. Okay, so we initialize with 0. I'm gonna try to make this. Let's visualize this. Sure, it'll be much better if we visualize it. Okay. So we have a nums array. We have 2, 7, 9, 3, 1. Okay. We want to loop through each of these values. So for I nums. Okay, so we start here at I. Sorry, I'm blanking out. My bad. We want temp is equal to the max of I 1. Sorry, in this case, our I is 0. So 0 plus rob 1. Oh, sorry, not. We're talking about the actual value here. Okay, 2 plus rob 1. 0 rob 2. 0. Okay. Tip is going to be this. Rob 1 is equal to rob 2. Okay. Rob 2 is equal to temp. So in this case we have rob 1 is equal to 0, and then rob 2 is equal to 2. Then we move to the next value here, so we're looking at 7, right? Then we do 7 we do 7 to 2. We got 7 here. Okay, rob 1 is equal to rob 2. Alright, so rob 1 is equal to 2. Rob 2 is equal to 7. Rob 2 is equal to temp. But temp is... yeah, is equal to 7. Okay. Okay. So let's go to next value. So we go to here to 9. And we do temp is equal to the max of 7 plus 9. Which is 16. Dude, I'm so confused what this is doing though. How does this get the right answer, bro? Like, okay, Rob 1. Bro, that is the worst Rob ever. Rob 1 is equal to temp is I, which is 9, plus Rob 1. Rob 2 is equal to seven. And we go Rob 2. Okay, Rob 2 is equal to 7. Rob 2 is equal to temp. So then we do I, which are at 9, plus Rob 1. $11. Okay, we move to this value here. We go temp is equal to I, 3 plus Rob 1, 10. Okay. Okay, we got something different here. Okay, so we got a temp is equal to I, 3 plus Rob 1, which is 10 over our max, right? So then we're going to return our temp is equal to 11. Rob 1 is equal to Rob 2. So this is 11. And then Rob 2 is equal to temp. And that's 11 as well. Let me move to this value here. Make Rob 1. Rob 2. We calculate our max. So our max is 1 plus Rob 1, 12. Rob 1 is equal to Rob 2, so 11. I plus Rob 1, 12. Okay. Yeah, we return 12. That's what our answer is. Wow. I still have no idea what we were doing there, bro. Like, I'm still so confused. 27931. It's so simple, but I don't understand like how. Hyper's equal. That's 399 in more detail. Oh, okay, I understand now. Okay, so we're either adding, this is adding the previous house. So this Rob 2 holds the previous house. And I plus Rob 1 is the previous house before that. So we either take, well, is 1 and 3 bigger than 2? It is, so we take that, right? We take this, 11, and we update that to Rob 1, right? Sorry, Rob 2 is equal to temp. And then Rob 1 is the previous one. Okay, I think I'm understanding it. Fuck me, dude. Let's get a new one. Let's do 2, 7, 9, 3, 1. Okay, so initialize 0, 0, right? Oh, whoops. 0, 0. We take I as a first house, so we have 2, 0, right? It's about 0. Make Rob 1 equal to Rob 2. Okay. And then Rob 1 0, 0, right? And then we do temp max, make Rob 1 equal to Rob 2. So then we go 2 here. And we got Rob 2. Oh, sorry, this is meant to be 0, sorry. And this is 2. Right? And we here. Right? And we do I plus Rob 1. So we got 7 here. But we got our previous house, which is 2. So now we make this 7. I plus Rob 1, which is 7. Make Rob 1 is equal to Rob 2. So we got 2, 7. Okay, so in this case here, we want to do, well, okay. Rob 1 is a previous house, so let's see, we got 11, or we just got 7. So then we make 11 equal to the previous, sorry, 7 equal to previous, then 11 is the one we're looking at now, right? Then we would do, we have 11, right? Or we have 7 plus 3, right? So here we'd have 11, we have 11 here, and then we'd have 11 as our max, right? Because we keep these two, 2, 9. So yeah, we keep these two, 2, 9, right? Or we'd keep, 2, 9 is 11. 7. Sorry, 10, 11. Right, so we'd have 10, 11, but we realize Rob 2 is 11. So we make Rob 1 equal to Rob 2. Rob 2 is equal to 10, so they're both 11. So that's our highest value, right? Then we take our final value here, 1, and we do, well, 12 is bigger than 11, so then we do 2, 9, 11. We make Rob 1 equal to Rob 2, so we still got 11, and then we return 12. Rob 2. Okay. That was a good problem. I mean, yeah, cool. We're gonna submit this. That was a good problem. It was tough, bro. That was tough. Oh my god, dude. Okay, let's take a look at Leetcode 75 problem. Maybe we can do a little bit of some 2-pointers and to the 2 Senate. What the? DP one I mentioned, house robber was one of them. Alright, let's go to 2-pointers. Let's do a 2-pointer solution. I think I did this one recently. From memory. December 12th. Okay. When I was back home in Australia. Given an integer array nums, move all zeros to the end of it while maintaining the relative order of the non-zero elements. Note that you must do this in place without making a copy of the array. Okay. I in nums. How do we want to do this? Is j is equal to the length of nums minus 1. So we make a pointer for the last array. We loop through. We see if, well, if I equal to 0, then we want to move so let's do, I think we're going to need the indice. If nums I is equal to 0, then we want to take, well, nums j, actually nums j, let's make temp is equal to nums j. Okay. And then we make, well, nums j is equal to nums I, then nums I is equal to temp. I think that should work, and then we obviously want to increment our j minus equal to 1. Equal to 1, we want to, I guess, increment, and then I guess we just want to return our nums. I think this should work, maybe, I don't know. Nope. Wait, does it have to be sorted, or? I want to print my nums after this each time. Okay, we do it, but then now when we get to the zeros, we're flipping them back. So that's what's messing it up. So how can we stop that? Okay, we need to make this a while loop. While I is less than or equal to j. I want to just increment I plus equal to 1. What are we getting here now? Bro, what? We have to sort it too, bro? No way, bro. Are you serious? Like, I'll just turn off the air conditioning. Oh my god, dude. Okay. We're gonna print 121300. Like, bro, what? Please fill up in the array. I thought we were just moving the zeros to the end, bro. Like, oh, okay. Oh my gosh, dude. Okay, let's kind of fix this. So obviously right now we're just moving the zeros, but here we kind of need to okay. I is less than j. Okay. To be honest, I'm not sure. Okay, well, nums I is equal to 0. Hang on 1 second. Oh. Okay. Okay, what's the best way to think about this? I think we gotta redo this code. If nums I is equal to 0, can we do while nums I plus 1 equal to 0, swap it? I'm gonna sneeze again, man. Oh my gosh, dude. Bless you, bless me. Ah, jeez. While num, see, I don't know if this is the right way to do it. Okay, so they were saying, well, if nums I is equal to 0 and nums j does not equal 0, then we can make the swap. So nums I, nums j is equal to nums j, nums I plus equal to 1, j minus equal to 1. Let's see what that. It's gonna be an infinite while loop. Okay. Let's print nums. Okay. Else if nums I does not equal 0, then nums and I plus equal to 1. Then maybe an else statement. We have 12 on 3. Do we have to sort in this, bro? Like, I don't understand. Like, I don't know. Bro, like, I'm so confused, bro. Like, I generally don't understand. Like, I don't think it makes a difference, bro. Like, I don't know. I don't know why this is not accepting. I'm actually mind blown. I don't know. This was my solution, bro. No freaking way, bro. What did I do here? For loop. I do here for right. If it does not equal 0. Bro. How did I not get this problem, dude? All zeros in the right places, or move all the non-zero numbers to the left places. This is what I did. Like, I'm kind of pissed, bro. A little bit. I don't understand how. Like, I don't get my solution, bro. Like, I'm following this. Given an integer array nums, move all the zeros to the end of it while maintaining the relative order of the non-zero elements. 1, 3, 12. Ah, the relative order. Okay, I messed up here. I guess we're just gonna need to do another loop. I guess we check, well, I is equal to 0. J. Alright, we can do for J in length of the range length nums. If J does not equal, if nums j does not equal 0. But we've lost the relative order though. I don't know how to. I can't keep track of that. You know, like this won't work, bro. This won't work. Bro, geez, we've been going for an hour and 20 minutes, bro. Jeez, man. I know I've done 2 problems. Oh my gosh, bro. Oh my gosh. Range, length, nums. We want to move, well, if nums I, it's not equal nums I, then sorry, if nums j does not equal 0. Nums I, nums j is equal to nums I, sorry, nums j, nums I, then we want to increment our left pointer. Alright. How does this fucking pass, dude? Like, one. Wow. Whatever, man. Bro. Is it this print statement, dude? So so stupid. Like, what is this guy doing here? Find range length nums. Nums I does not equal 0. D dot append nums I. Okay. So he's appending the zeros. He's making nums I equal to D. Nice. Jesus. Okay, we're gonna do another 2-pointer problem because I'm a little pissed about that one. Let's do this medium problem. Here's array height of length n. I have solved this problem. When did I do it? October 15th. Contains the most water. So you don't think contain is 49. I think the issue is how you can calculate the amount of water at each step. I think that's the hard part out of everything. It's 49. Okay. J is equal to the length of height minus 1. We loop through while I is less than or equal to J. Well, they can't be equal to each other, right? That wouldn't work. So, yeah. Then we want to calculate a formula to calculate. What would our formula to calculate this be? I don't really know. 8 times 7. 8 times 7 is 56, no? 8 times 7 is 56, so 56, but then I think they minus what's in between them, so 1, 2, 3, 4, 5, 6. Oh yeah. I think we just keep incrementing I and J in between each other, and we keep calculating what the max will be. We save the maxes. So I think so we save we create a variable here is like a max res is equal to 0, right? And then we calculate, well, Okay, well, obviously the area of a rectangle is width times height, right? To get the width, get width. Width would be width is equal to I minus j. Sorry, j minus I. Or we could just do I minus j and get the absolute. I mean, that works too, right? Okay, we get the height, right? So we would do the height is equal to the max of I guess it doesn't really matter, right? Like, well, it would have to be the minimum, no? It'd have to be the min of nums I, nums j. Then we calculate. So we would do, well, max res is equal to width times height. Sorry, let's do max res width times height. And then we increment I plus equal to 1, j minus equal to 1. And then we just return our max res. Then we increment here. That's nums is not defined. Oh shit. What is it? Heights or something? Height. No, height didn't. Jeez, that's descriptive. Why is this not subscriptable? Subscriptable. Is it? Yeah, it is a list of integers, dude. What? Yeah, bro. I don't know. Maybe we do left height, right height. Left height is equal to height I equal to height j. Then we want to replace this with left height, right height. An object is not subscriptable. Why? Why am I getting this error? Oh my gosh, dude. Bro, I cannot believe this, dude. That was the reason, bro? It's because we're overriding this variable here. I didn't even realize that. Okay, height. I minus height j. Okay. I do height x. minus I. Yeah, might be messing some stuff up. How are we getting an output of this? Like, output 0. Oh shit. Okay. We're not doing the max. Yeah. Why could this be the case? So we start here, right? We go, this is 1, and then we move here. Oh. Okay, it's because we're constantly moving inside the array, right? We're not actually making anything. So we need to fix this. This is our bug. This is our bug, bruh. Bug not incrementing / decrementing properly. Alright, so we need to check, well, if j is greater than I. Wait, no. Okay, if nums j is greater than nums I, then I plus equal to 1. Else j minus or equal to 1. I think that should fix it. Oh, bro, my god. Height. There we go. Okay. Nice. What the F trick? Okay. Kind of want to do a linked list problem, dude. Where are the linked list problems, man? Classic, man. Reverse the linked list, man. Classic. Let's do this one. Okay. Given a string s and integer k, return the maximum number of vowel letters in any substring of s with the length k. Vowel letters in English: A, E, I, O, U. Okay. Let's create a hashy here where we store okay, wait. Create okay. We create our hashy, right? We're gonna rename this hashy there, right? We're gonna create a left pointer, and then we're gonna do, well, for right in range length. Ooh, we got the length of strings. Maybe we convince this to nums is equal to the list of s. Cast that into a list. Range length nums, right? finish filling this and integer k, return the number of vowels in any such universe with length k. Okay. God, it's been a while since we've done a sliding window problem. String sliding window. Okay. Okay. What are we outputting? An integer. Oh, okay. So we take 3 letters. We check how many vowels. What's the maximum number of vowels in that? Okay. I understand. Let's create like a res variable too. Do our res variable first, and then we create our left pointer, right? If right minus left plus 1. If right minus left plus 1 is equal to k, then we want to check, well, no. How do we do this? Come on, think, Max, think. We'd want to start from a, do we want to start? What do we create? Usually do sliding windows. We usually can we add it to a hash map? Keep track. I mean, I was thinking we could just keep moving right and we would slice between left and right. And then we could loop over that sliced array. But that would be like extremely inefficient. It would be like an n squared solution or something. And squared log n. I don't know, something like that. But I'm thinking the better way is to somehow keep track of it like in place. So we would loop each time. So 1, 2, 3. Okay. So +1 is equal to, okay, let's lock in. Okay. This might not be the most inefficient solution in terms of space, but I think the way I'm going to use this is I'm going to create a dictionary. Right? Okay, and then we're going to check, well, if num's right in hashy, then we're going to increment count plus equal to 1, right? Wait. Num's right. Num's right. Plus or equal to... Dude, this is... Can we just check, well, for right and range length nums, if num's right in hashy, let's increment our... We have a count variable? God, man, there's so many variables up here. I'm locking in for you, Jones. Okay. In hashy, increment plus equal to 1, right? If right minus left plus 1 equal to k, right? Then we want to remove equal to k, then we want to check, well, if num's left in hashy, then we want to decrement count, right? Because we're removing that technically. Removing technically. The max of max res and count. So res is equal to the max of res then let's return our res. I don't know if this will work. Nums left in hashy. Oh, we're not incrementing left at all. I think that's why. Okay, we're not incrementing left here. That's also another reason why. So either way, we want to increment f plus or equal to 1. Nice, nice, nice. Good solution, good solution. We're gonna call it there. Turning my headset on. I'll let Jones have a little shout out, dude. Drake, do you want to make?
Dude.
Do you want to make a shout out to the video, bro?
Yeah, bro.
What's your shout out, bro?
Shout out.
Yeah, bro. You want to say something, dude, to the?
Yeah, shout out Tony. Tony's such a legend, bro. I love Tony. Shout out Max. Max is a legend, bro.
Let's go, dude. Let's go.
Best Australian in Illinois, maybe the United States for the
Let's
frat.
go. Let's go, bro. Let's go. Let's go.
Dead frat.
Dead frat. Dead frat. All right. Let's play. All right. I'm ending the video. See you guys tomorrow.